Hi children, how are you all? I hope you all are fit and fine, right? In the previous class itself, we have seen what is calorimeter, what is bomb calorimeter, and measurement of internal energy, measurement of enthalpy. Okay, all those things we have seen in the previous class itself, right? Today we are going to see the rest part of this unit. Okay, right. Are you eager to study chemistry? Okay, take your book and everything with you, right? Okay, let's start. Come on, let us start. Have you heard about the word lattice energy? What is lattice energy? This lattice energy is defined as the amount of energy that is required to completely remove the constituent ions from its crystal lattice to an infinite distance from 1 mole of crystal. It is defined as the lattice energy. So, what is lattice energy? The change in energy. Okay, lattice energy is defined as the change in energy that takes place, okay, when the separated gaseous ions are packed together, okay, to form an ionic solid. Okay, do you understood? So, for example, in NaCl, sodium chloride acetona, it gives sodium positive gas and chlorine negative gas. So that is NaCl. Okay, so it is a lattice energy. So change in energy. Okay, change in energy. எப்படி change in energy? சோடியம் கேஸ் ஃபார்ம்ல இருக்கு, குளோரின் வந்து கேஸ் ஃபார்ம்ல இருக்கு. ஆனா கன்வெர்ட் ஆனது வந்து சாலிடா மாறிடுது, NaCl சாலிடா மாறிடுது. So there is a change from one form to another form. So that is the change in energy that takes place when gaseous ions are packed together to form solid. The ரெண்டு gaseous ions packed together, combined together to form a solid. That is the ionic solid. You understand? So this is the lattice energy. Okay, the change in energy that takes place when separate gaseous ions are packed together to form ionic solid. Okay, do you understood? This is the lattice energy. Okay, are you clear with it? Yes, now we are going to see Born-Haber cycle. Okay, what is Born-Haber cycle? Okay, நேம் கொஞ்சம் வித்தியாசமா இருக்கா? What is Born-Haber cycle? Born அப்படிங்கிறவர் ஒரு சயின்டிஸ்ட், ஹேபர் அப்படிங்கிறவர் ஒரு சயின்டிஸ்ட். சாரி, they both are German scientist. Okay, so the Born-Haber cycle எதுக்கு கண்டுபிடிச்சாங்க அப்படின்னா lattice energy. Okay, lattice எனர்ஜியை கால்குலேட் பண்றதுக்காக. some lattice energies வந்து டைரக்டா கால்குலேட் பண்ண முடியாது. ஓகேவா? ஸோ அதுக்காக டைரக்ட்லி மெஷர் பண்ண முடியாத lattice எனர்ஜிக்காக Born-Haber cycle கண்டுபிடிச்சாங்க. Okay, that is Born-Haber cycle. So this Born-Haber cycle is an approach to analyze a reaction in energies. Okay, approach to analyze reaction energies. Okay, it was named after two German scientists. Okay, first one is Max Born, and next scientist is Fritz Haber. So Born-Haber, our both developed the cycle. Okay, so the cycle is concerned with the formation of an ionic compound. Ionic compound na positive, negative ரெண்டும் இருக்கு. That is the ionic compound. Okay, from the reaction of a metal with the halogen or other non-metallic elements such as oxygen. Right? Now, this Born-Haber cycle is primarily used in calculating lattice energy, which cannot be measured directly. I told you. Now, this Born-Haber cycle, it applies one law. That law is called Hess law. Okay, that law is Hess law. That is used to calculate the lattice enthalpy. Okay, that is used to calculate the lattice enthalpy. For example, okay, the formation of a simple ionic compound such as alkali metal halide. Okay, for example, the total number of, okay, the amount of all the energies. Okay, let us use this Born-Haber cycle for determining the lattice enthalpy of a NaCl sodium chloride ஓட energy level எவ்வளோ அப்படிங்கிறதுக்கு ஒரு டயக்ராம் வரையும் சரியா ஒரு டயக்ராம் இருக்கு you can see in your book okay ஒரு equation that's all அதில் first energy second energy third energy fourth energy எப்படி supply ஆகுது like that okay so this sodium chloride எடுத்துக்கிறாங்க formation of sodium chloride okay sodium plus chloride தான் sodium chloride form ஆகுது அது form ஆகுறதுக்கு 5 ஸ்டெப்ஸ்ல கொடுத்திருக்காங்க சரியா so since the reaction is carried out okay with the reactants in elemental forms and products in the standard states at a pressure level 1 bar so the overall enthalpy change of the reaction is also the enthalpy of formation for NaCl okay so also the formation of NaCl sodium chloride can be considered in 5 steps or 5 stages okay now the sum of enthalpy changes of these steps is equal to the enthalpy change for the overall reaction from which the lattice enthalpy of sodium chloride is calculated right so let us calculate the lattice energy of a sodium chloride using this Born-Haber cycle okay the first stage okay there is a formation of NaCl second stage atomization of sodium third stage ionization of sodium fourth stage atomization of chlorine fifth stage formation of chloride ion okay so this is this energy okay the value will come in a negative form so the negative sign indicates okay that the energy is released when sodium is formed from its constituent gaseous ions Na plus Na plus Cl minus that is the ionic form okay so Born-Haber cycle is primarily used in calculating the lattice energy which cannot be measured properly okay so lattice energy that is U அப்படின்னு எடுத்துக்கிறாங்க that is equal to delta H1 plus delta H2 plus half delta H3 plus delta H4 plus U. What is U? U is equal to delta HF that is final minus delta H1 plus delta H2 plus half delta H3 plus delta H4 okay finally delta okay teaching you problems okay after teaching the theoretical levels I will teach you all the problem examples okay in physics chemistry everything okay right I will teach you the problems also okay now you understand step there is 5 stages first formation of NaCl atomization of sodium second step third ionization of sodium further atomization of chlorine and next stage formation of chloride ion okay right next what are the aspects of second law of thermodynamics okay so we know okay from the first law of thermodynamics we know that the energy of the universe is conserved energy of the universe is conserved so let us consider the following processes okay let us consider the following processes a glass of hot water okay a glass of hot water over time it loses the heat energy to the surrounding and it becomes cold okay a glass of hot water எடுத்துக்கோங்க கொஞ்ச நேரம் ஆக ஆக அந்த heat energy loss ஆயிடும் surroundingல and it becomes cold isn't it have you experienced it next when you mix the hydrochloric acid with sodium hydroxide okay when you mix hydrochloric acid with sodium hydroxide it forms the sodium chloride and water with the evolution of heat hydrochloric acid that HCl reaction with sodium hydroxide NaOH so NaCl நமக்கு கிடைக்குது with the evolution of water that water will be evaluated as water vapor okay so in both these processes okay the total energy is conserved and are consistent with the first law of thermodynamics okay so however the reverse process okay that the cold water becoming hot water by observing heat from the surrounding on its own does not occur spontaneously have you heard anywhere the cold water becomes hot water by observing heat so though the energy change involved in this process is also consistent with the first law so however if the heat energy is supplied to cold water then it becomes hot so that is okay the change that does not occur spontaneously and then be driven by supplying energy but similarly the solution okay of a sodium chloride that does not absorb heat energy, okay, on its own to form a hydrochloric acid and sodium hydroxide. Okay, so but this process cannot be driven even by supplying energy. So from these kinds of our natural experiences, okay, we have come to know that certain processes are spontaneous while others are not. Some processes have a preferred direction. So in order to explain, okay, in order to explain the feasibility of a process, we need the second law of thermodynamics. Okay, so what are the aspects of second law of thermodynamics? The second law of thermodynamics has many aspects. Okay, we should first may appear different in kind from those of conservation of mass and energy principle. So first of all, predicting the direction of process. Next, establishing the conditions for equilibrium. Next, determining the best theoretical performance of cycles, engines, and other devices. Next, evaluating quantitatively the factors, okay, that preclude the attainment of best theoretical performance level. So these are the aspects of second law of thermodynamics. Okay, are you clear with it? Okay, that's all about the second law of thermodynamics aspects. Okay, next, entropy statement. Okay, entropy statement. Okay, the second law of thermodynamics, okay, introduce another state, okay, another function state, that is called the entropy. That is called the entropy. Okay, that introduce another state function called entropy. Entropy is a measure of the molecular disorder of a system, but the thermodynamic definition of entropy is concerned with the change in entropy, okay, that occurs as a result of a process. So this entropy statement, okay, it states that, okay, it is impossible for any system to operate in a way that entropy is destroyed. Okay, it is impossible for any system to operate in a way that entropy is destroyed. Okay, so the entropy of an isolated system that increases during the spontaneous process. Okay, so for an irreversible process such as spontaneous expansion of a gas, okay, that del S, that is greater than 0. So for a reversible process such as melting of ice, delta S equal to 0. So delta S system is equal to minus delta surrounding. So it becomes 0. Okay. Next, the second law of thermodynamics, which is Kelvin-Planck statement. Kelvin என்ன சொல்றாரு? Second law of thermodynamics. Kelvin வந்து என்ன சொல்றாரு அப்படின்னா, it is impossible, okay, for any device. It is impossible for any device that operates on a cycle, okay, in a process, a cycle, to receive a heat from a single reservoir and produce a net amount of work. Okay, it is impossible for any machine or any device, okay, to absorb heat, okay, to receive heat from a single reservoir and produce a net amount of work. So that is impossible. No heat engine can have a thermal efficiency of 100% or as far as the power to operate. So the working fluid must exchange heat with the environment as well as the furnace. Okay, so it is impossible to construct a machine that absorbs heat from a hot source and converts it completely into work by a cyclic process. Okay, so without transferring a part of heat to a cold sink. Okay, the second law of thermodynamics explains, okay, why an ideal engine or a frictionless engine cannot convert 100% of its input heat into work. So Carnot, on his analysis of heat engines, found that the maximum efficiency of a heat engine which operates reversibly depends only on the two temperatures between which it is operated. So efficiency is equal to work performed by heat absorbed. Heat absorbed. Okay, this is the Kelvin-Planck statement. Okay, the Clausius statement. Clausius என்ன சொல்லியிருக்காரு அப்படின்னா, it is impossible to transfer heat from a cold reservoir to a hot reservoir without doing some work. ஓகேவா, இந்த டயக்ராம் என்ன சொல்லுது, for lower temperature higher temperature, lower temperatureல இருந்து higher temperatureக்கு, lower temperature to higher temperature. So coldல இருந்து ஹாட்டுக்கு நம்ம ஹீட் ட்ரான்ஸ்ஃபர் பண்ண முடியாது. ஒர்க் டன் ஜீரோல இருக்கு, ஒர்க் டன் ஒன்றுமே இல்லை. ஓகே, அந்த டைமில் we are impossible to transfer the heat from a reservoir to a hot reservoir. Okay, do you understand? So this is the classiest statement of second law. Okay, are you agree with it? And what is the unit of entropy? The unit of entropy, that is joule K inverse. Okay, joule K inverse. Okay, and what is spontaneity and randomness? Okay, the careful examination shows that in each processes, okay, which is within the melting of ice, okay, ice melting ஆகுது, evaporation of water in the ponds. So there is an increase in randomness or disorder of the system. There is an increase in randomness or disorder of the system. So the water molecules in ice are arranged in a highly organized crystal pattern which permits the little movement. Okay, so as the ice melts, okay, the water molecules become disorganized and can move more freely. So the movement of molecules becomes free in the liquid phase and even more free in the vapor phase. So in other words, we can say that the randomness of the water molecules increases as ice melts into water or water evaporates. So both are spontaneous process which results in the increase in randomness. Okay, that is the entropy. Next, what is the Gibbs free energy? What is Gibbs free energy? The second law of thermodynamics introduced another thermodynamic function that is called the Gibbs free energy, so which finds useful in predicting the spontaneity of a reaction. So this Gibbs free energy was developed by Josiah Willard Gibbs. Josiah Willard Gibbs. So he originally termed this energy as a available energy. So to do work in a system. So this quantity is the energy that is associated with a chemical reaction that can be used to do work. This Gibbs free energy is an extensive property and it is a single valued state function. Single valued state function. Okay. So these reactions with negative delta H and negative delta S all have a negative delta G. So delta G equal to H minus Ts. That is the Gibbs free energy formula. Okay. So this Gibbs free energy, okay, one of the most important application of this Gibbs free energy is to predict the spontaneity, okay, of a reaction under a specific set of conditions. Okay, so a reaction that occurs under the given set of conditions without any external driving force is called a spontaneous reaction. So otherwise it is said to be a non-spontaneous. So in our day-to-day life, okay, we observe many spontaneous physical and chemical processes, okay, which includes the following examples. Okay, which include the following examples. First of all, a waterfall that runs downhill but never uphill spontaneously. Okay, a waterfall runs downhill but never uphill. Next, a lump of sugar, okay, that dissolves spontaneously in a cup of coffee but never reappears in its original form spontaneously. Okay, எப்போ பார்த்துருப்பீங்க வாட்டர்ஃபால் எப்பவுமே டவுன்ஹில் தான் ஃப்ளோ ஆகும், எப்பவுமே அது அப்ஹில் ஃப்ளோ ஆகாது, கீழே இருந்து மேலே போய் நிற்காது. பார்த்துருக்கீங்களா? ஆகாது. Okay, a lump of sugar, okay, a lump of sugar that dissolves spontaneously in a cup of coffee but never reappears in its original form. Okay, next, the heat flows from a hotter object to a colder object but never flows from a colder object to a hotter object. Okay, so these are the examples of spontaneity. Okay, spontaneity. From the above examples we can come to a conclusion, okay, that the exothermicity, okay, that favors the spontaneity, but does not guarantee. So we cannot decide whether it is not a chemical reaction will occur spontaneously solely on the basis of energy changes in the system. So we know that, okay, from the second law of thermodynamics, okay, that is a spontaneous process. Okay, it is a spontaneous process. So if the enthalpy change of a process is negative, then the process is exothermic. It may be spontaneous. Delta H is negative. If the entropy change of a process is positive, okay, then the process may occur spontaneously. The delta S is positive. Okay, understood? What is a spontaneous process? Spontaneous reactions or process that happens automatically and do not require any input energy to occur. Spontaneous process have a great tendency to proceed in one direction. It goes only in one direction. Okay, goes in its own path. Third law of thermodynamics, the entropy of a substance, okay, that varies directly with temperature. So the lower the temperature, the lower is the entropy. So for example, water above 100 degrees Celsius at 1 atmosphere exists as a gas. higher entropy. Okay, lower the temperature, lower is the entropy. So for example, the water above 100 degrees Celsius at 1 atmosphere exists as a gas and has higher entropy. So the water molecules are free to roam about in the entire container. So when the system is cooled, the water vapor condenses to form a liquid. So the water molecules in liquid phase still can move about somewhat freely. So the entropy of the system has decreased. Okay, on further cooling, this water freezes to form ice crystal. So the water molecules in the ice crystal are highly ordered and entropy of the system is very low. So if you cool the solid crystal still further, the vibration of molecules held in the crystal lattice that gets lower and they have very little freedom of movement and hence very small entropy. Okay, it states that if all the molecules in the universe stop moving, okay, a natural thing that molecules do, a state that is called the absolute zero would occur. All the molecules in the universe stop moving, then it is called absolute zero. Okay, children, that's all. This unit is completed and go through the one words. Okay, from 200 up to 218, I think so. 208 to 218. Okay, I have taught you, right? Go through it and do the one words. Okay, assignment I hope you may be doing or some children may have completed. Okay, assignments complete பண்ணி வச்சிருங்க. இப்போனாலும் உங்களை கூப்பிடுவாங்க. Okay, be very curious about your studies. Next class ல இருந்து நான் problem start பண்ணிடுவேன். Okay, right. Okay children, study well. Don't waste a single time. Have a nice